In today's note, we're just going to summarize linear and nonlinear relations. So we're going to look at the different examples of how we can represent linear relations that we've seen in the past, and we're going to compare that to what a nonlinear relationship would look like. So the first would be an expression, or you could think of an equation or a rule. So again, all different terms that mean kind of the same thing. But a linear expression will never have any exponents higher than 1. So that's the key thing. We're not going to see any exponents that are higher than 1. Commonly, we'll see the equation as y equals mx plus b. Again, remember that's the general pattern, that's the general rule, or the form of the rule that we'll see. But we can also see equations that may be like 0 equals 5y plus 2x minus 10. Again, looking at all of the terms there, or in all the variables, there is no exponent that is higher than 1. So that means this is a linear relationship. We could also see x equals 2, which we know is a vertical line. Again, there is no exponent higher than 1, so again, it's a linear relationship. So none of the variables have an exponent higher than 1, so that means that we are dealing with linear relationships in all of these examples. For nonlinear, when simplified, a nonlinear expression will contain exponents that are higher than 1. So for example, if I have something y equals x squared plus 3, because I have this exponent of 2, that makes this a nonlinear expression or relationship. I could also have something say maybe y squared equals x plus 4. Let's make it just 3x plus 4. Again, that variable y has an exponent of 2, so this cannot be a linear relationship. All the variables have to have an exponent of 1, or you won't see an exponent, because again, we don't need to represent or show that exponent of 1. If we see an exponent that's higher than 1, it has to be nonlinear. If we are looking at a table of values, so in a table of values representing a linear relationship, the change in y values will be consistent given a consistent change in x values. So as long as the x values are increasing by the same amount, the y value should also be increasing by a consistent amount. And the calculation for the slope will yield the same results when dividing the change in y by the change in x. So if we do our slope formula, or the m equals change in y over change in x, regardless of which 2 points we use, we should always get the same results. So for example, let's say I have x and y, 0 and 5, 10 and 20, 20 and 35. If I look at the change in y, I can see I'm going up by 15. The change in x, I'm going up by 10 every time. So the change in x is consistent, the change in y is consistent. So if I do my m value, 15 over 10, or 3 over 2, right, I'm always going to get 3 over 2 in this case, regardless of which 2 points I look at. So this table would represent a linear relationship. In a nonlinear relationship, the change in y values will not be consistent even if the change in x values is. So here, if I look at x's, so say 0, 1, 2, 3, I can see that the change in x is consistent. We're always increasing by 1. The change in y, for example, may be something like 1, 3, 8, 15. So I already know the change in x is always increasing by 1, increasing by 1, increasing by 1. The change in y, in this case, is increasing by 2, then we increase by 5, then we increase by 7. So we can see this change here is not consistent, even though the change in x is consistent. So when this is the case, when the change in y is not consistent, then we have a nonlinear relationship. So again, the change in y values will not be consistent even if the change in x values are. A graph is a pretty easy one to tell, because a graph of a linear relationship will display a straight line, right? And we've seen multiple examples, right? It's either positive slope, negative slope. We can have vertical lines, horizontal lines. It's all just different examples that we can see. A nonlinear relationship will be anything other than a straight line. So again, it could look something like that, where it's curving. Maybe it's a circle. Actually, I'm going to take that one out because we won't see that till next year, right? But it could be a curve like that. It could be a curve going like that. It could be something like this, right? As long as it's not a straight line, it's a nonlinear relationship. So looking at a graph, it's very easy to tell the difference. And finally, description of growth pattern. So this could be a pattern or a word scenario, but a growth pattern that is linear will show the same number of tiles or blocks added or subtracted at each step. A nonlinear growth pattern will show a different number of tiles or blocks added or subtracted at each step. So let's say I look at 3 positions. Oops. So 3 positions for each. Let's say, keep it easy. So 2 blocks, and then say the next one, I add 2 more blocks. And the third one, I add 2 more blocks. So every time I go up a step, I increase by 2. And that would be linear. For a nonlinear one, let's say I start with 1, I go to 2, then I go to 6. So here, I increase by 2, and then I increase by 3. So this would be nonlinear, right? Because I'm increasing, or I'm adding an inconsistent number of blocks, or I'm adding a different number each time. So this is just an example of the different types that ways that we could see a linear or nonlinear expression represented, and just kind of the comparison between the two, how they would differ. In terms of actual word scenarios or in writing, we won't get into that much. Most of the word scenarios that we cover will just be linear relationships. So again, just make sure you know the difference and are able to tell or identify if it's either linear or nonlinear, and you can use this table or chart as a guide to help you with that.